Well, first of all, thanks for inviting me to be here today and be able to speak about social values for ecosystem services, or SolVES. Some very brief background before I just jump into the presentation. This was actually born a few years ago, the intersection of, well, my need for a master's thesis and my current PI in Denver, Darius Simmons' interest in looking at developing methods and tools for how we could spatially, explicitly take a look at social values and how they relate to ecosystems and ecosystem services. And add that into the mix with some other connections. We're able to work with a social scientist, Dr. Jessica Clement, who at the time was with Colorado State University, who had previously conducted some social surveys for the Pike and San Isabel National Forest in Colorado. So we had that data available so that I could build a prototype, the initial prototype for SolVES, around that. And so keep in mind, you'll be seeing examples of results that are focused on that work from the Pike and San Isabel National Forest, but keep in mind the broader context of this, what SolVES serves as a framework for looking at the relationship between social values and the underlying ecosystems. So, jumping right in, what is SolVES? It's a GIS tool for incorporating non-monetary social value information into the spatial context of ecosystem services assessments. What are we talking about? We're talking about calculating and mapping a 10-point, what we refer to as just a value index, which is a standardized quantitative metric, again, non-monetary, non-market indicator of stakeholder perceived social values that often correspond to cultural ecosystem services such as aesthetics and recreation. Example here, a map of the PSI, I think is aesthetic value. It's really not critical what it is, but just the general idea. We have this value index with the cold to hot gradient with the hot colors, representing higher intensity values, social value intensities across the landscape. And also, just as it exists as a tool, it's an ArcGIS 9.3 toolbar, and that's just a little screen capture of how it looks when you have it in ArcBat. And how does it do this? What it does, it derives a value index from points that have been mapped in a value and preference survey of stakeholders to identify locations which they associate with specified social value types, again, such as aesthetics, recreation, future value, intrinsic value, etc. We'll see a whole example of a topology pretty soon here. But anyway, this is kind of an example of, for the actual survey itself, for what this was done. This is 2,700 points in aggregate from all the surveys that were taken. So everything that we did with SolVES, we were able to derive from this point data, along with some other non-tabular or non-spatial data. Also, what it does is it models a relationship between the map value index and the underlying environmental variables as you select them. For example, in contexts like this, elevation, land cover, distance to roads. And in a different context, like a marine context, like for Chesapeake Bay, we may be talking more like bathymetry and bay grasses instead of what you see here. With the goal of it is to assist land and resource managers with analysis and communication of trade-offs relating to social values. And with the spatially explicit element of it, we're able to look at, okay, different groups of stakeholders, and are there different areas on the landscape in which there are conflicting values, which stakeholders on different side of issues have shown on the map. Or are there complementary values being represented that might give some idea of how to approach different land management, resource management situations. And part of what's important with the survey component as well as the spatial element are the ability to segment stakeholder groups according to whether they favor or oppose particular uses of the land, whether it be motorized or non-motorized recreation, wildlife habitat, resource extraction, that type of thing. And uses can be replaced with any kind of other issue or parameter that might allow you to, again, effectively segment the stakeholders. And this is an example of the type of values topology we're talking about in regard to social values. This traces its roots back further. 20 years ago, Ralston and Kufal suggested this forest value topology with some similar elements as the topology here. Greg Brown, who's I can't remember the university currently in Australia he's at, but he did a lot of work with Pat Reed, who was with the Forest Service, developing different and validating the topologies that they've been referred to as forest values, they've been referred to as community values, ecosystem values. We use the term social values here, but it's a lineage of using these types of value types for this type of indicator. Also, as part of the surveys, I should mention that as well as mapping points that correspond to these different value types, survey respondents are also asked to allocate a theoretical $100 never mind the fact that I'm saying dollars, it could be points or anything else. There's this this 100 points to allocate among these different values. That gets aggregated and it's used to weight the points categorically. So all aesthetic points will get weighted by the total amount of value allocated to aesthetic, etc., going through the different types. And now quickly moving on, earlier in 2012 we released SolVES 2.0. We've already jumped to that point. There were several changes to that that made SolVES 2.0 more flexible than the initial SolVES that we put out. The most important change we made was its integration with what's called the maximum entropy modeling software. And it's actually originally developed to model geographic distribution of species using presence-only data. But what we saw was an analog here. We saw an analogous situation between point mapped by survey respondents to the points where a species was observed. In some way, there's an indication of value for that point being put on the map, relative or species being present on the map, and it has something to do, as we theorize, with the underlying landscape conditions, the different environmental variables you could use to express this relationship. Why do the points fall across a landscape as they do? And here, moving a little bit more on that, environmental variables serve as constraints to be satisfied by an estimated probability distribution. Simply put, with entropy, you're talking about with not having any information, there's like an equal likely probability of there being a presence or not across a landscape. Once you start getting more information in the form of these variables, you start to improve on what you don't know, and you're able to predict a higher probability in some areas versus others. And in this context, what we end up with is a higher probability equaling a higher social value intensity, which gets reflected in the value index I mentioned previously. Some other elements of SolVES 2.0 and the Maxent integration part of that is Maxent produces this logistic output which gets used in conjunction with what SolVES already produced as a weighted kernel density output, and those work together to generate social value maps that take into account the placement of the points by the survey respondents along with those underlying environmental variables. And from this, we're also able to generate models that describe that relationship. And finally, one of the things that Maxent provided for us were these area under the curve statistics that allow us to, with a single statistic, evaluate if it's a good model for the study area. It also allowed us to pursue further our idea of how might we be able to take these models and apply them in different areas in the form of value transfer, which is full of caveats when you're applying value transfer, but we'll talk a little bit more about that later. And this is just a very broad overview schematic of SolVES 2.0. There's three separate models, really. The first two work in conjunction with each other in a sequence. The first thing you do with the Ecosystem Services Social Values model is you select a particular stakeholder group you want to look at, which is defined according to their attitude or preference regarding a public use, again, such as they're for or against oil and gas drilling in the national forest. And from that selection, there's a determination made as to the maximum value and the location of that highest rated value from all the different social value types across the landscape. This maximum value, again, gets used by the second model in the sequence, value mapping model, where now the user selects a particular social value type they want to look at. Okay, I want to look at aesthetic value across the landscape. They make that selection, and that aesthetic value surface is then normalized against this maximum value. So everything in the context for it for the calculation of the value index is based on what is the overall maximum value and how does everything else scale to that. So that's the model does that, and then with what we get from Maxent, there's map output that is generated along with these statistical models that are generated, which there's a bearing on the next model, value transfer mapping model. But important thing right here is once you've done this step, then you have a value index map and some environmental metrics that are summarized to go along with that, and we'll see an example soon. Again, the value transfer mapping model, that runs separately from these two models, but there is a dependency in the terms that it relies on statistical models that have been previously produced from analyzing survey data to attempt to apply this in a value transfer format to areas where survey data does not otherwise exist. In this case, a user selects a stakeholder group and a social value. The appropriate model is located and applied to the corresponding environmental layers, and here in this case you get a predicted value index map and corresponding environmental metrics. Here, the next couple of slides are just schematics, which it's a little bit of mechanical detail of how it works, but I do think it's important, again, just to reiterate where these values come from, this quantitative aspect comes from. And this just kind of digs down deeper into the level from that overall summary. Here, a survey subgroup is selected. And this is meant to indicate that, okay, well, a certain survey subgroup, they have certain points that they map, so those are grabbed from the overall sampling of points. Weighted kernel density surfaces are generated for every value type that was included in the survey, that was included in your value topology. And what's indicated by these colored squares is simply on every surface you're going to have a maximum value. Then what happens? Well, then you create a surface that reflects that maximum value for each value type, and ultimately, well, one of those is going to be the maximum across all those. It might be for biodiversity, as is indicated here, but it might be for aesthetic or cultural, etc., etc. And then moving on, this maximum grid, keep this in mind, moving to the value mapping model, which is the second model that was shown in the overview, you select the social value type, which now has this kernel density surface that exists in the database. It's called up, and it gets normalized against that maximum grid identified in the first model. And it goes through a standardization process which produces this kernel density value index, which with the first version of SolVES was essentially your final value index surface, but it's now more of an intermediate surface. And on that, the value index ranges from 0 to 10, so you're going to have a maximum value on this surface, which might be 10, might be 7, might be 4, what have you, but you end up with a surface that is just that value because that's going to get used along with the MaxScent data to produce your final maps. And here what you have is the same survey points that were selected previously for the particular survey group, along with the appropriate environmental layers that you've selected, and the processing instructions are sent to MaxScent, which produces logistic output which ranges from 0 to 1. And essentially what's going on here is a communication between what SolVES is really doing and then what MaxScent is really doing, because MaxScent has no awareness of the relative value of people who favor motorized recreation value aesthetic more than value recreation value type more than aesthetics. It doesn't have any indication of that. On the other hand, SolVES, what it's produced over here, it doesn't have any kind of indication of what environmental factors might be influencing that. So essentially with this multiplication step, you're actually having the two models inform each other to produce a final value index surface. And it also, MaxScent also produces these lambda files, models, which become the basis for conducting value transfer. But getting back to the final value index surface, once you have that surface, it's an integer surface which produces zones so that you can complete zonal statistics to get a rough idea of the relationship between what's going on with the environmental layers and as versus a change in intensity on the value index. So you have this series of metrics created for both quantitative and categorical data. And this is, in ArcMap, is an example of what you'd see after you process the models and asked it to display results. You have this composite, like this is an instance for Pikenson Isabel National Forest. For the stakeholders who oppose oil and gas drilling, this is the aesthetic value map for these, for that group. And along with that, you have some you can't read this, I understand, but this is, for instance, elevation. You've got value index on the y-axis. You have average elevation on the x-axis. So you can start looking at relationships that that exist between these different metrics: elevation, slope, distance to roads, distance to water, etc. And then you also have, I mentioned the AUC statistic. You have a very, gotcha. You have a, oops, didn't mean to go yet. Get my time right there. But very quickly, you have these AUC statistics summarized here, which give you a quick heads-up indication of if it's a good model for the study area, given the environmental variables we've used, and also an indication of if it might be a decent model to try to use for value transfer. And this is just to show after you've done all these spatial analyses and produced all this output, like even in a tabular form, you can kind of summarize your results and start looking at some patterns that exist, like within a certain survey group, like for those who favor motorized recreation versus those who oppose oil and gas drilling. You can start, you start seeing, some patterns. For one thing, like aesthetics is routinely pretty high valued target relative to some of the others, and so with some exception, recreation comes in pretty high from time to time. Again, this is just to give you an idea. You can start looking at these in terms of even without the spatial element in front of you, just comparative information. Then value transfer very quickly, because I'm running out of time. You're generating models describing the relationship between the value index and environmental variables in areas where you have survey data available to you, and then you're applying those models in what should be, or to hope, are socially and physically similar areas where no survey data are available. And I haven't put a schematic with this one for sake of time. I just very quickly just visualize, okay, Pike San Isabel National Forest here in Colorado. We had survey data, produced a model, and we transferred it. Okay, how would that look? How do we predict a social value map for that same stakeholder group and that value look for Grand County, Colorado? And that's, again, just to visualize the spatial component. And finally, for future research and development, we're continuing to pursue opportunities to apply and test the tool where spatially explicit social information can be followed through to management decision in both terrestrial and marine environments. We're identifying environmental variables that better describe ecosystems and improve the modeling of social values in a variety of environments. We're also evaluating how SolVES results compare to and complement more traditional statistical methods of social survey data analysis, and also validating value transfer functionality in other selected studied areas where primary survey data are available. Also, we need to address compatibility with ArcGIS 10, which we should be doing this fiscal year, so we'll have a SolVES 2.1 that works with 10 as opposed to just being locked into 9.3 at the moment. And down the road, it'd be nice to see this all as a web-based tool, so we're not always trying to keep up with a particular version of ArcGIS, etc. And here is the website address for links to the tool itself, sample data, sample surveys, and contact information is there as well. But that is my presentation on SolVES. Thank you.